Welcome to lesson 3.11. This is about the rule of 4 today, how we link words, graphs, tables, and equations all together because they all are part of the same thing. So can you please pause the video and try this warm up on your own by graphing the snail, the height of the snail as it crawls up a pipe. So here's a quick start for you of what I have chosen to do for my scale. I know that I needed to go from 0 to 40 on my time. Here we go. So I was able to get up to 50. I just made 3 boxes be 10 seconds. So that means 5 would be like 1.5 boxes. So I can follow that as I go along. I labeled my axis with my unit, seconds, and my category, which is time. And then my height went from -2 up to 50. So I needed to make sure that I included a little bit of negative section in my y-axis. A lot of times a pipe from your house going down from your roof will actually end underground, and that's what we see here. This snail started underground and crawled up the pipe from the inside, and then eventually he's getting towards the top of the house. Well, 50 centimeters. He's going up the house a little bit. So please plot your points if you haven't yet, and then draw a line of best fit to match the data. So this is the line that you should have gotten. So now let's go through and interpret it. The first question is calculate the first differences. Is this relationship linear or non-linear? So what we're going to do to calculate first differences, just a recap from yesterday, is bottom minus the top. So we do need to check to see that the x-axis or the x values go up by a consistent amount. Do they go up consistently? Yeah, what do they go up by? 10. Thank you, Alina. So they go up by 10 every time. Because those are consistent, that means that our first differences can actually mean something. If you get to the x side and they're all wonky all over the place, then there's no point in doing first differences. They won't mean anything. So what is 11 minus -2?
13.
Thank you very much. 13. Can we just say the rest? 24 minus 11. 37 minus 24. And 50 minus 37. Great. So this is the first differences, or sometimes we call it delta y, because that means the change in y, right? How much did it change from one line to the next? So we need to see that they are all the same, which means it's what type of relationship? Everybody? Yeah? Linear. So it is linear. So when I did my graph, it makes sense that it became a perfectly straight line, right? I could take my ruler and draw through there. So we have graphed the relationship. Is it linear or non-linear? It is linear because first differences are constant. Remember, first differences we can also call delta y, or the change in y. So is this variation partial or direct? What do you think?
Partial.
Why partial, Krish?
Because it's y value starts at -2 and there's a slope.
And what?
And there's a slope of 13 over 20.
Okay, so that is absolutely true that there is a slope, like we have an angle to this. Is there a slope if it was direct variation? Yes. So what is the key thing that you said?
The y intercept starts at -2.
Excellent. So we're going to write, okay, it's partial because my starting point is not at the origin. It's somewhere else. And in fact, because we are given the table of values, we don't even have to read it off the graph. We can just read the starting point from the table of values. So that starting point was 0, -2. If it was direct, what would that point be? 0, 0. Perfect. Okay, what's the initial value of the height? Robin? Perfect. So we can say, okay, yeah, we know that it was 0, -2. So the initial value is -2. We can see it on the graph. We can see it on the table. Use the graph to calculate the slope. Now, when I say use the graph, this is what I'm looking for you to do. I'm looking for you to find 2 points that go through nice grid lines. There is only one point, like data point from the table, that's exactly in the middle of a grid point. What is it?
50.
50 and 40, right? 40 on the X and 50 on the Y. But we need to find another one, and we can't use one of the data points because none of the other ones are nice. So is there another nice one there? So the second grid point I see is here at 16 and a half seconds and 20 centimeters high. So those are my 2 grid points, and now I need to figure out my rise and my run. So I'm always going to start at the point on the left, and I'm going to count up whatever I need. So how many am I going up? Well, that's from 20 to 50, so this is a positive 30. The rise is going up by 30. Can everybody see that? And then I'm going to go across to just finish off my triangle here. And I went from 16.5 to 40. So my difference is 23.5 to the right. I am always, always, always going from the left to the right. So it says use the graph to calculate the slope. We know that the slope is rise over run. Now, normally we wouldn't do like a string of equal signs across, but the way that the sheet is laid out, we don't have room. So the rise was 30 and the run was 23.5, which gives me about, what, Krish?
1.3.
1.3. We can also get this from the table of values. So TOV is table of values. We do the change in Y divided by the change in X. So we have the change in X right here. It was 10. And we have the change in Y right there. It was 13. So the change in Y was 13 divided by the change in X is 10, which actually gives me the same number. Question 6, interpret the slope as a rate of change. Well, we just calculated the slope here 2 different ways, using the graph like the question asked, and then just confirming it using our table of values, right? The change in Y divided by the change in X. So when it says interpret, now it's asking you to include the units. So we have to take into consideration that our Y values are about time, our height is about time, pardon me, and our X values are about seconds. So we have the rise, the height, divided by the time. So centimeters per second. So we just now state it in the context of the problem. Therefore, the snail travels up the pipe at 1.3 centimeters per second. Next question is, how does the slope relate to the first differences? And we've already talked about this a little bit by saying, oh look, we can calculate the slope from the graph, rise over run, or from the table of values. So let's just write that down. It is the slope is equal to the first differences divided by the X interval that we talked about in the last lesson. Or we can say the change in Y divided by the change in X. So let's take all of this information and write it together to get an equation. So we know that this is a partial variation, which gives us the general equation of Y equals mx plus b. So now let's plug in the things we know. So we know that the slope is 1.3, right? The slope is 1.3, that's my m. And we know that the initial value is 2. What letter represented the initial value or the fixed cost? Alina? B. Perfect. So we're just going to plug those two things in. Y and X stay the same because those are the variables, the things that change when we plug them into the graph. So we say Y equals, and then we're going to plug in our M, which was 1.3. We're going to keep the X the same. And then our B was -2. So, I just wrote a plus. I wrote the plus because I said Y equals MX plus B. But when I go to plug in my number, it's actually -2. So will I write plus -2 plus -2? Vihan, what will I write?
In brackets, -2. Or
So once I see that I'm actually plugging in a negative number, I don't need my plus sign. I'm never going to write a plus and a minus beside each other. So I'm going to erase my plus because it was a mistake. And now I'm just going to write -2 only. So that is my equation that I just took because I calculated my initial value and I calculated my slope. Those get plugged in for M for slope and B for y-intercept. So what is the relationship in the context of the question? It is this. As time passes, so as time gets further along, that's increasing X, the snail travels further up the pipe. Is that a positive or negative correlation? Positive, excellent, because as time passes, that's increasing X. As I move to the right, then, as I move to the right on my time, then the height also increases. So we can see that this graph is pointing up to the right, so it's a positive linear relationship. So the last example just connected words talking about the story of a snail, the table of values, the graph, and the equation together. So all 4 parts of that story were linked with math. The next example, we're just going to be looking at this equation, y equals 2x minus 5. So we're going to create a table and we're going to create a graph. So the first thing I want to look at is my x's that go there, and my y's, which are going to be equal to 2x minus 5. So that's how I'm going to start my table of values. Remember, the x's are the things that you pick, right? These are independent, so you choose the x values. For now, you're just going to pick a couple of negative, 0, and a couple of positive numbers. So it will look the same pretty much every time at this point. So we're going to have -2, -1, 0, 1, and 2. And then we're going to sub those in to the y side to figure out what the y value. It's like an input and an output. So we're going to have 2, and then instead of x, we're going to write -2 in brackets to substitute, minus 5. 2 times -1 minus 5. 2 times 0 So just using our brains, we figured out our x and our y value, and these come together to give us a coordinate point. So remember, our coordinate points are x, y. So we're just going to read them straight off of here. There's my x, and there's my y. So -2, -9 is my first coordinate point. And I'm going to plot that on my graph. So I'm going to read over to -2 and then count down. 1, 2, 3, 4, 5, 6, 7, 8, 9 down. And I'm going to meet those together. So I don't need any of that stuff. Let's get my next coordinate point is -1, -7. So -1 is here. And then this was -9, so 2 up will be -7. 0, -5, so 0 is there. 1, 2, 3, 4, 5. It's going to be my big point. You please finish the rest. Once you have all your points plotted, you're going to connect the dots with a ruler. It should be a perfect line. if you get, you know that this equation is a line because we can recognize it looks like y equals mx plus b. So if you plot your points and they don't look like a line, you have messed up something. Either you plotted your points wrong, so these coordinates are correct, but you didn't put them in the right spot, or your calculations were wrong. If you know it should be a line, make sure your points look like a line, or else it's just weird. Something is going wrong and you need to look into it. This is what your line should look like. Don't forget a couple things. One is to put arrows on the end, because if I'm given an equation, I only picked 5 values to put in, but I could pick my x value to be 100 and have something that's way, way, way off over here somewhere. I could make it huge. So I need to put an arrow showing that it's going to keep going. I could pick something much more negative, negative 1,000, and I could still get a point way, 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 way down here somewhere. So I need an arrow to show that that keeps going. The last thing that I need to make sure that I do is label my y and my x axes, and I need to state my scale. My scale is a 1-to-1 ratio because every one box represents 1 unit. The question on the back says, use the graph to determine the rate of change. So we're going to choose 2 nice points, and we have lots of nice points here, so it's totally up to you what you want to pick. I'm just going to pick this one because it goes through nicely, and I'll choose this one. But you can pick any 2 nice points that you want. Remember, nice means that it goes through both an x grid line and a y grid line. And then I figure out the rise and the run. So from here to here, I'm going up 1, 2, 3, 4 boxes. So my rise is positive 4 because we're counting up. And my run is 2. The run will always be positive because we're counting to the positive side of x. Okay, we're always counting to the right. So my slope, according to my graph, so this is what you're writing for part B, rise over run. The rise was positive 4, the run was 2, so my slope is 2. Oh, and look at that. This number matched with what I knew was m in my equation. They should be the same here as what you have in the equation here. Okay? Now let's use the table of values to do the same thing. I'm going to find the x interval. So what are my changes in x? So what does it go up by? What's my x interval? 1, exactly. So it goes up by 1, 1, 1. It's consistently 1, so that's great. And then my change in y, what is this going up by? 2, 2. I actually should have them going up the other way. The first difference is -7 minus -9 is 2. -5 minus -7 is 2. Same thing all along. So if I'm going to find my slope from my first differences, I'm going to use the change in y divided by the change in x, which was 2 divided by 1, which is just a slope of 2. So remember, it's the first differences divided by the x increments. For example 2, we're going to read the question. Jock earns $25 per day plus $9 per 100 flyers for delivering the advertising flyers. This is an example of using words to describe a relationship. So we're going to use this rule of 4 to describe the relation in 3 other ways. So this was the words right here. We're going to use numbers in a table of values. We're going to make a graph, and then we're going to put it all together into an equation. So let's just do the beginning, and then you can keep working on it yourself. So we know that he earns $25 per day, no matter what. So even if he doesn't deliver any flyers, he earns $25. So X is the number of flyers. And then our Y is going to be his total pay or his earnings. So if he sells 0 flyers, he's going to be paid $25 no matter what. If he sells or delivers 100 flyers, he's going to earn that $25 because he earns that every day. And he's gonna earn $9 because he delivered 100. If he delivers 200, he still gets that $25, that's constant. But this time, he's delivered 2 sets of flyers. So that's gonna be 9 times 2. So if we're looking at his total pay, we've got 25 is his total, 34 is his total pay, 43 is his total pay, and you can keep going, please, to finish this. Once you're done, I want to see a proper graph with the labeled X and Y axes and a line of best fit. So check in and make sure that your table of values looks the same as mine. We're going up in increments, groups of 100 flyers, because for every 100 flyers, he earns $9 more. So we should see that, oh, he's gone up by 100 flyers, his pay should go up by another $9. So 100 flyers, $9 more pay. 100 flyers, $9 more pay. Please now pick a good scale for your graph and graph it. Pause the video and check after you're done. So here's the scale that I chose. I chose to go up by 2 boxes is 100 flyers. So every 1 box is 50 flyers. So I should have that in my scale. So on the x-axis, 1 box is worth 50. And on the y-axis, 1 box is worth $5. I can see that here when I go up by 1 box. So 2 boxes was 10, so 1 box is 5. So there's my scale. Make sure to include that. Now plot your points. For example, the first one is 0, 25. So here's 0 on my x, 25 on my y would be there. Once you get your points, draw a line, please. Pause the video and keep going. So here's the graph that you would have gotten if you used the same x and y scales that I did. We can figure out the slope in 2 different ways here. We can use the graph or we can use the table of values. And it's always good to check that they match each other. So I'm going to find 2 nice points on my line. So remember, this point was 0, 25. And I need to have another good point, and I see that is going to be kind of at this 70 here. My line isn't perfect because it was digital, excuse me, but we can see that from this table of values here, it was exactly 70. So I've got 570. So I'm going to do my rise and my run. So I'm going over how many? Well, I went from 0 to 500. I'm not counting boxes, right? 1, 2, 3, 4, 5, 6, 7. I'm not going to count those because the scale is different here. So I need to actually look at my units. So this is a run of 500. Runs always go to the right, so they will always be positive. And then I'm going to have my rise, kind of finishing off this triangle. And that goes from, if I look on my scale, 25 up to 70. So the difference between 25 and 70 is 45. And it's pointing up, so it's going to be positive 45. I know that my slope is rise over run. So I'm going to plug those 2 things in. Rise means up and down, so 45. And the run was 500. So my slope on the graph is 0.09. And you can use that with your calculator to figure that out. We can also get that from our table of values. So I need 2 things. I need the change in x, which is our x increment, and I need to know the change in y, which is our first differences. So what's the x increment here? Well, that's 100. I can see that every time it needs to be consistent. And when I do bottom minus top for my first differences, every single time I should get a difference of 9 because that's how much I'm getting paid more. So if I want to find my slope here, I'm going to do the first differences divided by the x interval, which is the change in y, divided by the change in x. So I have 9 divided by 100, which gives me 0.09. So that should be the same. And this makes sense. What does it mean? It's saying that you are paid 9 cents for every flyer that you deliver. Let's finish off this rule of 4 because we were given words as the question, we made a table of values, we made a graph, now we need to finish it off with the equation. So we need to define our x and our y. Now we know that our x is the number of flyers delivered, that's the independent variable, the thing we freely chose, and then the y variable, that dependent variable, was the pay. Our pay depends on how many we deliver. So let's write that down. So now that we know what x and y mean, and we've made it very clear, we're going to start from y equals mx plus b. This is the general equation, and we're going to plug in the things that we know. So we did just calculate the slope. So there's our m, and that's what we're going to plug in for here. And we also know our b. There's two ways that we can know that. One is to look at this point, our b, on our y-intercept. But I can also scroll up to the top, and I can find out what it says on our table of values when x is 0. So that's our starting point. So it's the y-intercept is the same as the initial value, which is 25. So if I deliver 0 flyers, I will be paid $25. So y equals 0.09x plus 25. Don't forget that this number here was our slope. This is the value, how much we get paid for one flyer delivery. Right? We know that it's $9 in the question. It told us it was $9 for every 100 delivered, which is the same as 9 cents per one flyer. Please go finish the homework, look in the homework checklist to see what it is, and email me if you have any trouble.